Okay, welcome to the lecture series of Math Genius. Okay, today we will be discussing this February March paper 6297009. Okay, starting off with the first question. Okay, so we have to calculate a 98% confidence interval for the population mean time. Okay, so starting off, we have some of t given, t square is given. So first of all, we will be finding the mean, and we will be finding this t bar, and t bar is equivalent to sum of t upon n. So sum of t is given 4820 divided by n, that is 60. This is equivalent to 80.33. Then we have the mean for the variance for this 60 samples. Whenever we are asked to find the confidence interval of a population mean time, right? So we would be finding this variance, and we would be applying this CTL, that is the central limit theorem. Okay, n upon n minus 1 bracket sum of t square upon n minus t bar h. Okay, so n is 60 upon 59 bracket, that is given 392051 upon 60 minus this 80.33 square, and we are getting a variance of 82.0. Okay, since we have to find the confidence interval, so it would be mean, or you would be saying t bar plus minus z score into root t square upon n. So this is the main formula. So t bar is given, so we can write it down 80.33 plus minus what is the z value. If you look over there at the 98 percentage, so you would come in, and since it's a confidence interval, so both sides, like a two tail you would say. So the value is coming 2.326 root 82.09 upon 60. Okay, so our final value is coming 77.6 less than equals to mu is less than equals to 83.1. Okay. So those of you who are not familiar with it, right, it's a thing that you will have to study later on as well in the years. Explain why it was necessary to use the central limit theorem. It is necessary because the population distribution is not known to be normal, and the sample size is large. Right, as we can see that n is greater than 30, so the central limit theorem applies. Okay. Now coming to this question, they are saying that find the value of the constant k, right? So area under the curve, okay, area under the curve is what, 1, because it's a PDF, so half, this is area of triangle, half into height into base equals to 1 So k square is equals to 4, k is equals to 2. Then find the value of k for x for which 0 is less than this, and hence find p of x. Okay, so first of all, we would be finding the gradient. Gradient is equivalent to half k minus 0 upon 0 minus k, that is coming minus half. Okay, now we have the f of x is equals to minus half x plus 1 PDF in the range of 0 and 2. Why 2? Because k is coming 2. Okay. Now e of x, simple integration, x into f of x. So it would be minus half this function x square plus x limits. This would be integration. Okay. Now integrating this. So we are getting this would be 3 comes downward. So 1 upon 6 x cube plus which becomes x square upon 2, 2 0. So it becomes minus 8 upon 6 plus 4 upon 2. This is coming 2 over 3. This is coming 0.667. Okay, next. Find the value of p such that p of, this is in brackets, p is less than x is less than 1 is equivalent to 0.25. So it means that the limits are 1 form of p of this function. This is equal to 0.25. Okay, so this becomes minus 1 upon 4 x square plus x 1 comma p is equals to 1 upon 4, and after inserting the values it becomes minus 1 upon 4 plus 1 minus 1 upon 4 p square plus p is equals to 1 upon 4. Then we have 3 upon 4 plus 1 upon 4 p square minus p is equals to 1 upon 4. And finally, we can put it in the form p square minus 4p plus 2 is equals to 0. And p is coming 2 plus minus root 2. Okay. So one value is coming 3.414. The other is coming 0.586. Okay. So we would reject this value. Because why? Because this is less than the value of z. Okay. And right, and this 3.414 is basically greater than 2. So we would accept this value. So the value of p is equals to 0.586. A lot of algebra is involved in this question. Next. Okay, this is on average the building. He takes large sample value from the find the mean of the calculate the value of that test which are higher on average than the building. Higher means one-sided, right? So one-sided means one tail, right? So because he wants to ascertain whether heights are higher, higher means greater, so one-sided means one tail, right? Carry out a test at the one significant level. Okay, so in terms of testing, the first thing is to determine the hypothesis. So this is null, H naught, or alternate. We have right now looking at the test statistics value. One-sided, so just be careful, it's a one-sided test. So we are on this side, right? So test statistics is equivalent to 2.41, okay, and at the 1%, 2.326, we reject H naught, okay. This is given to us, right? 2.41, and the value is from the test statistics 2.326. So we reject H naught. Significant evidence that buildings heights are on a higher side. Okay. Now it says that second part, question number 4. On average, 1 in 400 discs are faulty. The number of faulty networks is 1000. So we have N and P. So it means that X is following binomial. So X is following binomial. What is N? N is 1000. P is 1 upon 400. Okay. Now we have to state an approximating distribution for this. So we then approximate this with Poisson, and it has only one variable, right? Poisson has one variable, that is the mean, right? So this is mean NP, 1000 into 1 upon 400. This is coming 2.5. Okay. So X is following Poisson 2.5. Since NP is less than 5, so we would approximate using Poisson. So this is important, right? Otherwise, normal would have been taken. So using this distribution, find the values of each. 4, it would be E minus lambda, lambda power x on x factorial, e power minus 2.5 dot 2.5 into 4 upon 4 factorial, and we are getting a value of 0.1336, 0.134. Similarly, for the values between 2, so it means that there are 3 values, x equals to 2, 3, x equals to 4. We have calculated this for the other 2's are left. So it would be E minus lambda bracket lambda upon 2 plus lambda 3 upon 3 and lambda 4 upon 4. And finally, we are getting a value of 0.60. Now it says that using a simple suitable approximating distribution to find the probability that in a random sample of 700 chips. So now 700 chips, so 700 n into p. This is the new mean or the new lambda, right? So x is following Poisson 1.75. P of x is greater than equals to 1 because it says what? There will be at least one faulty. It means 1 minus P of x equals to 0. Okay, so 1 minus e power minus 1.75, and we are getting a value of 0.82. 5. So it says that there is an n 5.1 comma this, and the other n values are this. Find the probability that the total volume of juice in 3 randomly chosen large bottles is less than 25. So L is normal 5.10, 0.0102, and the other is S, that is small. It has what? 2.51, 0.003. Large and small. Okay. So in 3 randomly large bottles, right? So 3L is equals to 3 into mean 15.3, and if you recall, the variance would be 3 squared. Okay, so over here it says 3 randomly chosen large bottles and 4 randomly chosen the other bottles. Okay, so variance of 3 is like 3 multiplied by 0.0102. Similarly for here 4L, sorry 4S, so 4 into 2.51, mean it would be 4 into 0.0036. Okay, so 3L plus 4S is falling normal 25.34. Summing this value, this is coming 10 point something. Okay, 10.04 comma 0.045. So This is coming somewhat 0.0306. This is coming 0.0144. Okay, we have to find this less than 25.5. So Z is less than, so it would be 25.5 minus 25.34 upon root 0.045. Z is less than 0.754. They using the tables 0.754, 0.774. Now part B, find the probability that the volume of juice in the larger is at least twice the volume in the randomly small. So L is greater than equals to 2S. First thing is this, we can write it L is minus 2S is less than greater than equals to 0. Again E, L minus 2S is equivalent to simple E of L minus 2 of E of S. It is coming 0.08, simple. But for variance, as you recall, the variance is not subtracted, and since it says twice, so the values first of all are added to square variance of S. It is coming, final value is coming 0.0246. So most of the marks are for this, right? L minus 2S is following normal, 0.08, 0.0246. It is asking that is at least twice the volume of this. So Z is greater than 0. So it would be P 0 minus 0.08 upon root 0.0246. P of Z is greater than equals to minus 0.5106, 0.510. This is coming 0.6950. 6. So carry out a hypothesis test at a 5% significant level, 4 out of 25. Okay. And first of all, we have to determine whether it's one way or two way. 8% adults of a certain risk after advertisement has increased. Okay. So he's asking for the increase one tail test. So H naught P is equals to 0.08. H1 P is greater than 0.08. Increase it says one tail test. Okay, 5% significance. He finds that 4 out of 25. Okay. Okay, now, so test statistics is X is equals to 4. This is the trick part. Okay, so for the critical region, we would be using P of X is greater than equals to 4. This is coming 0.1351. Then we find P of X is greater than equals to 5. This is coming 0.0452. less than 0.05. So when it is less than 0.05, so it signifies that the critical region is x is greater than equals to 5. So since 4 is less than 5, test statistics not in CR. So not significant evidence to reject H naught. So we accept H naught. Therefore, there is no increase in the proportion of center cars. One mark for this, one for this, and this working of 1 to 2 marks. Now part B, which type of error, type 1 or type 2? Okay, so if you recall, probability of type 1 error is basically what? Probability of rejecting H naught, right? And over here is, okay, so over here, what you would say type 2 error occurs when a false H naught is accepted. Okay, right? So since our conclusion in the previous part, in part A, is about accepting H naught, so a type 2 error might have occurred. Find the probability of type 1 error. Now, what is type 1 error? First of all, you should be familiar with this. Type 1 error probability is probability of rejecting H naught. This is the confusing part, right? Just you have to remember this part, type 1, type 2 error. Right? So if we say H naught is rejected for x is greater than equals to 5, and if we look at from part 1 or part A, we would see that the value is given 0.052. So therefore, the probability of type 1 error is 0.045. Okay. So done with this exam. Hopefully you guys have understood this.